Hello, my name is George Cody, and I'm the president of Imaging Engineering, and I'm here to give you an introduction to Insight Essentials and Insight Enhanced upgrades for the GE RNF systems. We're going to go over a few frequently asked questions in this presentation, and in particular, why do I need to upgrade my GE Advantex Legacy or Precision 500, especially as it applies to the longevity of the systems themselves versus a few end-of-life components. We're going to look at what benefits the upgrade brings to the system, and in particular, the lower dose and better image quality. How does the system change my system? We're going to talk about what's removed and what's added. And finally, does this upgrade make financial sense, especially looking at throughput for the room and the changes in reimbursement. GE over the years has sold over 7,000 RNF systems. They're by and far the market share leader. They have about a 64% market share. The rest is split between Philips, Siemens, Toshiba, Shimadzu, others. What this does is it guarantees you a good supply of parts and trained service engineers for many years to come. There are only a few components on these systems that are actually truly end-of-life components. And in particular, what we're looking at is the camera tube. These camera tubes have not been in production for about 7 years, and they are all going bad at this point. What you'll find is that your image quality will burn out considerably, like you see here with the smearing, all the whites merged together. You'll see your blacks being compressed as well, image retention. You'll also notice that your dose will increase considerably as well. On the Precision 500, it's a little bit different. It's a little bit more modern, so it has a CCD camera. But its main component that's not been in production for a couple of years is the image intensifier. And that image intensifier will go bad in about 7 years. They all have a burnt square in them. There are no more new ones available anywhere. So when that fails, there is no replacements, and those systems are down. There's nothing that can be done except our upgrade. And we replace the Windows 95 Saturn computer. And it is worth noting that this Windows 95 Saturn computer cost about $50,000 when it fails, and a used image intensifier, a couple years old, is going for about $40,000 right now. One of the first benefits I want to talk about is the lower dose. A lot of times we're asked, do you really lower the dose? And the answer is yes. We should be practicing a LARA, as low as reasonably achievable. But what we're finding is most sites are practicing more along the lines of a MALA, as much as legally admissible. This is because the camera tubes are faulting, and in some cases the image intensifiers are failing. Here's some example of dose readings at a recent upgrade that we performed. And here you'll notice the before dose readings of 0.3 R per minute. And after we do our upgrade and we're doing our orthogram protocol, you'll notice we have 10 times less dose, 0.03 R per minute. So this really is quite substantial dose reduction. So one of the questions, how do we achieve this? But first, we recently had a dealer meeting, and I do want to play a short from that video in which we demonstrate the dose reduction. This time it's in a different unit of measure, grays per minute, but please indulge me while we play that video. So this is our screen. Here's our floral loops. And before we leave this, I just want to point out, we have the ability to edit these floral loops. So within the software, you can come in and select a floral loop. You can play it right in here if you want, and you can choose, what amount of this loop you're going to send to PACS. So it gives the ability to pick and choose what gets sent. this is useful in modified barium swallows where sometimes you have those patients, they're just trying to swallow and they're trying and they're trying and it just doesn't go. So you don't really want that to go to pass. So we have that ability. And then when you close and you go to send, it asks, do you want to send the original study or do you want to send your edited? We're not sending anything because I don't have a PACS set up here. So we're going to just close this. So I'm going to start another exam. You'll see that this is essentially a 1, 2, 3 process. It is very simple, very clean. Notice this, and I really want to stress this. This drop-down menu. This is unique to Legacy, and it's something no other company in the world does, and it really is mind-blowing. So the Legacy is well known as a continuous fluoro system. The Legacy, the stock Legacy, only does 30 frames per second. I'm going to turn off fluorosave because we don't need it. Now, I'm going to bring Brian back and make sure it's the right Brian. So Brian is spotlighted. So Robin, if you would, make a few seconds of fluoro while Brian shows the dosimeter. So we're going to let our fluoro stabilize. Okay. That's good. Notice that our fluoro at 30 frames per second is 66 microgray per second. And our dosimeter, as you can see in the image, is sitting tabletop. So this is essentially patient-absorbed dose, or I'm sorry, skin entrance dose. Now I'm going to start another exam. This is where the magic happens. This is what nobody in the world can do. And guys, you may go in, they're going to be like, you know, maybe we need to buy that $600,000 Siemens system because it's half the dose of the GE system. But wait till you see this. Go ahead and fluoro. Now we're going to let it stabilize because the image has to come down, right? Because we had it stabilize at the higher value. Okay, come off. And you can see the slope from the dosimeter, which is very evident. We went from that 60-some microgray to 15 with the same image. We're reducing dose by over 70%. And this is really particularly useful in arthrograms. We also have customers using this for their upper GIs. We're also adding 0.2 copper. That means we're doing an 80% patient-absorbed dose reduction. This is something just a few years ago was magic, an impossibility. Nobody even ever tried to do this. And when we presented this to the FDA said, whoa, what do you mean that much dose reduction? You have to back this up with evidence. And we did. That's why it's FDA cleared. So, I mean, this is nothing to sneeze at. And this is exclusive to the Legacy, I want to point out. So I'm going to go ahead and close out this study. Again, the system is very clean, very easy to operate. We can come in and we can review patients. And I also want to point out, we have a dose report. This dose report goes to the PACS system. Notice that we have exposure time and total dose, which is also displayed to the user. So the user gets to see that, and these are things that typically on the Legacy you do not have. So as part of that update, we're providing additional dose tracking, not just dose reduction. We're asked sometimes, how is it that we can accomplish such incredible decreases in dose? We have something which we call variable frame time. Typically on a 30 frame per second system like the GE Legacy, you have to produce enough dose, enough radiation in 33 milliseconds to satisfy the image brightness for fluoro. So you have to produce a pretty high dose because you're taking all of these frames. For us, however, we're able to change the timing of either the detector or the camera. And what we do is we can change that timing And in the case of 15 frames per second, we increase it by 66 milliseconds. We have the ability to set any frame rate we want, but we've chosen 30, 25, 15, and 7. What this means is we don't need as much dose because we're accumulating it over time. Basically, it's the same thing as mass on an exposure. High MA, low time, low MA, high time. The real effect of this is related to temporal resolution. However, the effect isn't as pronounced as one may think. So these images here are from a GE 9800. And what you'll see is this is fluoro noise reduction, FNR, with an FNR of 1, meaning the lowest noise reduction you can choose, and FNR of 4, the highest. Typically, the systems are set for between 2 and 4. These are last image hold from fluoro, just to show the motion blur of the frame integration. So even at 30 frames per second, you actually will get quite a bit of motion blur, loss of temporal resolution. Whereas with our system, because how we are acquiring that data, and just simply by extending the frame time, you'll notice that our temporal resolution, even at 7 frames per second, is higher than a OEC 9800 with their standard lowest noise reduction. It's really quite impressive. Also, some people may compare this to a pulsed fluoro system, but a pulsed fluoro system is really quite different because in a pulsed fluoro system, the standard frame time is 10 milliseconds for almost all the systems. So in a 15 frame per second system, you only have 10 milliseconds. So you need to produce quite a high dose in 10 milliseconds, but then you turn X-rays off. The effect of this is that, let's say you're doing 15 frame per second exposure, you're only going to collect 150 milliseconds of data out of 1,000 milliseconds. That's an 85% motion data loss. So in high motion studies, and in particular you're looking at swallowing studies, modified barium swallow, upper GI, etc., or range of motion for the shoulder, a pulse fluoro system, this stroboscopic effect, will be quite negative. In high-speed stuff like cardiac and vascular, that's where pulse fluoro can really shine. In addition to the variable frame timing, we do have added filtration that we put in. So we add 0.2 millimeters of copper on the systems. On occasion, it may be 0.1. It does just depend on the efficiency of the tube and the image intensifier. Typically, adding copper flattens the image, but we have the ability to have contrast adjusting curves, lookup tables, to restore the contrast in order to correct for the flatness that the copper may bring. This allows us to match any image quality needs, any contrast scale that's needed. Of course, we have the standard edge enhancement and noise reduction. And finally, we do have a dose report, which is done as a JPEG that goes to PAX, a photo file. And this photo file includes exposure time and total dose. One of the ways in which we can improve the image quality is through those image curves, those lookup tables. That allows us to match the grayscale that's needed by the radiologist. It also allows us to tune it to the system. We get rid of the old CRTs. Some of your systems may still have CRTs, and we provide medical grade diagnostic monitors from ELO. Also, which most people aren't aware of, even the GE Precision 500, it only produces a 512 by 512 8-bit deep image. Our system is a true 1024 by 1024 12-bit deep, so we do provide more image data, just in general, which provides a higher resolution. What we saw like at a recent installation that we just did, maximum resolution was 1.8 line pairs. Before the upgrade, when we were done, we were sitting right at 4 line pairs per millimeter. Some examples of our image quality. And so here is a modified barium swallow. And one of the reasons why I want to point out the modified barium swallow, and I recognize that most of you are probably doing arthrograms, but when you look at this image, the modified barium swallow allows you to evaluate the fluoroscopy for motion, motion blurring, frame integration, noise, but also grayscale. Notice we're able to see through the skull, through the jaw, but we're also able to see, and honestly, I think this is rather amazing. I've actually not seen this, I think, in any other fluoro image. We're actually looking at the trachea, and we can see the esophagus clearly on this modified barium swallow. We got soft skin detail. Really, it is quite an impressive system. On our spots, they're very sharp. Here again, the grayscale is adjustable. I know some radiologists like a black and white image, some radiologists like a little bit more grayscale, but we can meet those needs. It is nice to see that we're not burning out in the lungs, but yet we are penetrating through the esophagus as needed. An additional benefit is HIPAA compliance. Be it the GE Legacy Advantex with the DRS or the Precision 500 with the Saturn computer. Basically, anybody that walks by can see the patient list, HIPAA violation. So in our system, we have a very simple menu-driven system. 1, 2, 3, you're starting your exam. But whenever you close your exam, using our close exam here, you always go back to a home screen. The home screen does not show patient data. You have to click Database Browser to get to be able to view the patient history. So this does allow us to ensure that we have good, positive HIPAA compliance. One of the other benefits is that we provide Windows 10. Your older systems are still running MS-DOS. The Precision 500 is running Windows 95. And it's kind of like it's time to upgrade to Windows 10. Just getting the Windows 95 systems off your network should make your IT people quite happy. So one of the other questions to review is what is removed from the system and what is added. It does depend on the system, but generally speaking, we remove the old VIC camera because that's where the camera tube is, and we provide, if it's inside Essentials, we provide a modern CMOS camera. We also provide a TSO, tableside operator, which allows the doctor to be able to perform last image hold, be able to set his spot frame rates, image flip, reversals, all right there in a nice little color touchscreen. We replace the monitor, and that's really nice because, again, we're getting rid of that old CRT. So that's an important thing. The CRTs just don't have the dynamic range that these medical grade ELOs do. So we do add a PC. You can see right here. We use a little, it's 4 inches by 4 inch PC, which performs all of our imaging. So we add a PC here. We also add a digital interface board. This is where we connect into what's called the real-time bus and allows us to control the system. Now, the format of the digital interface board changes between the Legacy and the Precision 500 just simply because the connectors are different, but it's still very much the same thing. And of course, on the Precision or on the Legacy, when we remove the image intensifier, it really does change the look and feel of the room. It is quite impressive to not see that II, especially on these Precisions where you have these gigantic 16-inch IIs. When you remove those, it just changes the dynamics of the room completely. One of the other questions we need to ask is, does upgrading the equipment make financial sense? After all, in the end of the day, if it doesn't make financial sense, it's not worth doing. So as we look at this, if you go out and buy a new room, you're going to spend $400,000. And you got to ask the question, does it increase your throughput? No. Does it increase your reimbursements? No. So what does buying that new room get you? It actually just increases your service contract cost, because the new room is going to cost you about 10% of the purchase price for a service contract. So you're going to run about a $40,000 a year service contract. And any new equipment that you buy, it's only serviceable by the OEM. The nice thing about that GE Advantex Legacy Precision is that there's plenty of parts support out there. There's also plenty of companies with trained engineers to service that equipment. What we've been striving for with our Insight DRF platform is the ability to upgrade from the oldest GE rooms, the GE Advantex LFX, through MPPU, SCPU, and the GE Legacy. These 4 systems can utilize either our CMOS camera or our 12x12 detector. The Precision 500 we've really designated for our 17x17 flat panel detector. The 17x17 detector just doesn't fit in the Legacy spot film device. Some people have suggested utilizing C-arms as an alternative to their forarms when their forarms fail. The dominant C-arm out there is the OEC 9800. The OEC 9800 is an MS-DOS system. And if the plan for the future is to utilize a system that uses CRTs and boots in MS-DOS, then I have a nice DeLorean that I would like to sell you. The OEC 9800s are not going to be around much longer. So really, some thought needs to be given to how you're going to approach the solutions for the next 5 to 7 years. Thank you.